Hi everyone. So for our project, we were tasked with the Movia optical camera system. We were Team 26, and the project was done by Anthony Masulo, Ian Connolly, Matthew Davis, and Daniel Setti. For a general overview of the project, we were tasked with creating a system for determining the layout of the environment of a robot using an optical camera and numerical analysis. Essentially, the robot would systematically move the camera to detect changes in the environment, and from these changes, the basic geometry of the environment and its relation to the robot could be determined. And using this data, the robot could systematically decide its course of movement within the environment most accurately to not run into objects or other things within the environment. So for some of the solutions and technologies that we explored, mainly we utilized Python as our main language to interface between the various components of the system. For the first component of the system, it was the actual physical robot, which made use of an Arduino board to then interface between the different software components that were able to determine the robot's environment. Going off of this, we also made use of OpenCV, which is a library of programming functions mainly aimed at real-time computer vision to help detect changes in the environment of the robot. So using the data that the robot was taking in and the video, we were able to use various parts of the OpenCV library to detect changes in its environment. And finally, from that, the last component of the system makes use of Unity, which is a well-known game engine, which we were able to then create a dynamic environment layout for the environment to basically visualize that environment that the robot was in. So in terms of our accomplishments, as of now, our system successfully makes use of a basic webcam and an Arduino board to take in video from its environment. In addition to this, using this video input, our system is able to interface with our software for detecting changes in the environment. And lastly, our system is able to construct a Unity environment based off of data collected in this environment. However, the team is still finalizing the total integration of each of these modules. The end product will be a system that moves the robot while taking in video. This video will be then processed by our software to detect objects in the environment and their distances from the robot. And finally, this data will be used by Unity to construct visualization of the robot environment. In terms of the challenges we faced, there were definitely a lot of roadblocks along the way of this project. For one, the team was not familiar with OpenCV technologies prior to the inception of this project, so each of the members of the team had to quickly learn the potential use of this library so we could then apply them to the project. Also, our system is designed to be modular, so one difficulty the team faced was bringing all of these separate modules together to function as one complete system, and evidently we're still working through this to try to finalize one complete system. Lastly, since we were forced to work remotely, only one of the team members could work on the robot, making data collection, testing, and overall integration of the modules more time-consuming, which is also part of why we're still finalizing this. Lastly, we want to thank our sponsor, Timothy Gifford of Movia Robotics, for his dedication to our project and his helpful insight throughout the entirety of the project. He was always there to answer our questions and give us guidance for different things that were confusing us throughout the project. Also, thank you to our advisor, Professor Agnieszka Barenson, for her guidance and feedback along the way. This project proved very insightful for our team as we were able to apply the different learnings we had received from our undergraduate career to a practical application and demonstrate this through this design project.